So in this video, we're going to go over the problems that are similar to what's in your Unit A test part 2. So let's look at this first problem. It's asking us to find the inverse of f of x equals the square root of x minus 5. So remember, the first thing we're going to do when we're finding the inverse is we're going to replace that f of x with y. So we have y equals the square root of x minus 5. Okay, so remember, now we need to find the inverse. In order to find the inverse, we need to take x and y and we're going to swap them out. So everywhere I see a y, I'm going to write an x instead, and everywhere I see x, I'm going to write y instead. Well, now what I need to do is I need to solve this equation for y. Remember, I wanted to get it into y equals form, so my y is by itself on one side of the equation. So in order to get y by itself, I need to get rid of all the things that are with y. Well, if you look here, I have a square root and then I have a y minus 5. So the square root is kind of putting everything under it, so I need to first undo that square root. In order to undo the square root, I'm going to do the opposite, which is squaring both sides of this equation. When I square both sides, I get x squared equals, and then the square root and square cancel each other out, and I have y minus 5. Now, to get y by itself, all I need to do is get rid of this minus 5 that I have right here. The opposite of minus 5 is plus 5, and remember, anything I do on one side, I have to do on the other. Be very careful here because I added the 5 after I squared x. So that means that that 5 is going to stay on the outside, okay? So this is going to be x squared plus 5, and that's equal to y. Remember, the final step is to write this using inverse function notation. So f inverse of x is equal to x squared plus 5. Remember that the inverse of a square root function is a quadratic, so whenever we're writing these, we need to include our domain restrictions. We're going to restrict the domain, and so what we're going to do is we're going to take that part that's being squared, right? So the x is being squared, and we're going to say that's greater than or equal to 0. So this is how you find the inverse of the function described in number 1. So now let's try this problem. So this is a square root equation. So it wants us to just go ahead and solve for x and then show all our work. So when we're solving for x, remember, we want to basically get x by itself on one side of the equation. So we have the square root of 8x plus 1 is equal to 5. Okay, so the first step, remember, when we have everything kind of trapped under that square root, we need to go ahead and undo that square root by squaring both sides of the equation. When we square both sides, we get 8x plus 1 is equal to 5 squared, which is 25. So now all we need to do is use our opposite operations to go ahead and get x by itself. So remember, generally we were going to add and subtract before we do the multiply divide. So I'm going to start off by undoing this plus 1, and I can undo that by subtracting 1 from both sides. When I subtract 1 from both sides, I get 8x equals 25 minus 1, which is 24. And now all I need to do is divide both sides by 8 so that I can get x by itself. So that gives me a final answer of x equals 3. But remember, when we're working with square root equations, we always want to make sure and check our answer. So I'm going to go ahead and plug it back into the original equation. Okay, so the equation I started off with. So I have 8 times, instead of x, I'm going to plug in my 3. So square root of 8 times 3 plus 1. And I want to check if that's equal to 5. So that's telling me that the square root of 8 times 3, which is 24, plus 1, is equal to 5. And that's telling me that the square root of 25 is equal to 5, which is in fact true. So we know we found the correct solution. All right, so now in number 3, I want you to compare and contrast two transformed square root functions, right? We want to compare and contrast how g of x equals negative 1/3 square root of x minus 4 and h of x equals 4 square root of x minus 5 have been transformed from the square root parent function f of x equals the square root of x. So I know in the problem it gives you few questions to think about, right? It says think about the vertical transformations, think about the horizontal transformations, and also think about the key features. So what I'm going to do now is I'm going to go ahead and graph these two functions in Desmos, and that's going to be how I fill in this chart, so it gives me an idea of what I'm going to write about. Okay, so now I have these functions graphed, so let's think about how they compare to each other and to the parent function. So in black right here, you can see I have the square root parent function, f of x equals the square root of x. The blue function here is g of x, and then the green function here is h of x. So let's think about vertical transformations, okay? So vertical transformations, remember, another thing we can do is look at is the values of a and the values of k in each of these equations. If you would rather use a study guide with a chart to figure these out, you can do it that way also. So the vertical transformations, well, you can see the top graph, the blue one, that's actually been reflected, right? So g of x, we would say it has a reflection, okay? And that's over the x-axis. That's one vertical transformation that I see. Another thing that I see is that it's also been vertically compressed, right? You see how this is not as tall as the original parent function. So we would say it's vertical compression, right? And that's also aligning with the fact that we have that one third right there. And then we also have this -4 on the outside, right? So remember that -4 on the outside is the reason that this graph has been shifted down 4 units. So we would say it goes down 4. Okay. Now let's look at the vertical transformations of h of x. So h of x has that 4 in front, and that's our value of a. So you can see this graph is actually vertically stretched, right? It's taller than the parent function. So we would say vertical stretch. This graph does not have a value of k, so we don't actually have a vertical translation. So vertical stretch is going to be the only transformations we have. So now let's look at the horizontal transformations of g of x. Okay, so g of x horizontal transformations, remember, it's going to be what we see under the square root. Notice that this has actually no horizontal transformations. Okay, so we would say none. And let's go to the second function, the 4 squared of x minus 5. You can see that it does have that x minus 5. If we look at the graph, you can see that the effect is that the graph has been shifted to the right 5 units. Okay, so we have a horizontal shift. Now let's think about the key features. Okay, so the key features, remember, are domain and range, maxima or minima, and the intercepts. Okay, when we're talking about square root functions. So let's describe the domain of g of x. Okay, so the domain of g of x, you can see that it starts off at 0, right, and it heads to the right to positive infinity. So we would say 0 to positive infinity. The range, okay, well, let's look at this one. Well, this is a different one because it's actually going down, right? So the range, remember, we go from lowest to highest. So since it's going down, the lowest point is actually going to be negative infinity, right? It's not even a point, it's like more like an idea, right? It's going to be heading down to infinity and then coming up from there. So the upper part of the range is actually going to be -4, right? Because that's where the graph stops. Now let's think about maximum or minima. Well, since this graph is actually headed down, it's going to have a maximum point, right? It has a maximum of -4 because that's the highest y value, and that occurs at x equals 0. And finally, we want to think about intercepts. Okay, well, if we look at this graph and you can scroll around in Desmos to see, you can see that it has no x-intercepts, right? It's never going to cross the x-axis. But if we think about y, okay, you can see here that this maximum actually is the y-intercept also. So it has a y-intercept at 0, -4. Okay, now let's go over to h of x. So h of x, you see 4 squared of x minus 5. Okay, let's think about the domain and range. Okay, so the domain is actually not going to start off at 0. The domain actually starts off here at 5, right? Because that's the leftmost point. And then this graph is headed to the right. So we're going to go from 5 to positive infinity. The range, well, the lowest y value is going to be right here, right? It's going to be at y equals 0, and then it's headed up from there. So we're going to go 0 to positive infinity. Let's think about whether it has a maximum or minimum. Well, since this graph is headed up, it's actually going to have a minimum value, right? The lowest y value is at 0. So we would say it has a minimum of 0 at x equals 5. Okay, that's the lowest point. Now let's think about some intercepts. Well, it does in fact have an x-intercept, right? So it's not like the other function. It has an x-intercept, and that's going to be at 5, 0. And let's think about, well, y. Well, it's actually not going to cross y, right? Because it starts off at x equals 5, so there's going to be no y-intercept. Okay, so I've kind of summarized the questions here in this table, but what I want you all to actually do is write out 3 sentences when you're writing out your answer. So hopefully this table kind of gives you an idea of how to brainstorm and look at the features of these functions. And then now you can take this information and write out 3 sentences to summarize what you found.